Dear learners, welcome to the new lecture of Engineering Chemistry lecture series. In today's video, we will cover the topic breakpoint chlorination, which includes definition, complete process of chlorination, breakpoint chlorination curve, advantages of breakpoint chlorination. So let us begin with the definition of breakpoint chlorination. Breakpoint chlorination is a water treatment process that involves the addition of chlorine to water to achieve the complete disinfection. So, it may be defined as the chlorination of water to such an extent that microorganisms as well as bad taste and odor present in water are completely destroyed. So basically, breakpoint chlorination ensures the complete disinfection of water. This is essential for ensuring that water is safe for consumption and free from all the pathogens. So, now we are discussing the complete process of chlorination. As we know that chlorine is added to water for its disinfection purpose. That means for its complete purification, chlorine is added. When we add chlorine into the water, it basically acts on four types of impurities. First is inorganic impurities. Second is organic compounds and amines. Third one is the chloroorganic compounds and chloramines. And fourth one is the bacteria present in the water. The sequence of attacking the chlorine onto the impurities remains the same. That means firstly chlorine attacks on the inorganic impurities, then after complete ending the inorganic impurities, next addition of chlorine attacks on the organic compounds and amines. After that, chlorine attacks on the chloroorganic compounds and chloramines, and lastly the chlorine attacks onto the bacteria. After all, the chlorine added to the water completely destroyed all type of inorganic compounds, all type of organic compounds, all type of chloroorganic compound and chloramines and the bacterias. When we added chlorine to water, first it reacts with the inorganic compounds and it oxidizes all the inorganic compounds present in the water. So in this way, the inorganic compound completely removed from the water after oxidation. After the complete oxidation of inorganic compounds, next addition of chlorine will react with the organic compounds and amines. When chlorine attacks on the organic compounds, it converts these organic compound into the chloroorganic compound, and when it attacks on the amines, it converted the amines into the chloramines compounds. So when we add chlorine in the water, firstly it get consumed with the inorganic compounds. After that, it get consumed with the organic compounds and chloramines. Due to the reaction of chlorine onto the organic compounds and amines, it forms chloroorganic compounds and chloramines into the water. But the chloramines respond to test for the estimation of chlorine in the same way as free chlorine. Therefore, in this stage, it seems that chlorine in the water increases, but actually what is increasing in this stage? The amount of chloramine increases. Why it is increases? Because chlorine attacks on the amine compound or amine impurities in the water and get converted these amines into the chloramines, and these chloramines compound give the same test as the free chlorine give. Therefore it seems that free chlorine increases, but actually at this time chloramine concentration in the water increases due to the attack of chlorine onto the amine compounds present in the water. When all the organic compounds and amine compounds converted into chloroorganic compound and chloramines, the next addition of chlorine results the destruction of the formed chloroorganic and chloramine compounds. That means after that when we add the chlorine, it get consumed into the destruction of chloroorganic compound and chloramines. So what it means that first when we add chlorine, it forms chloroorganic compound and chloramines. When all the organic compounds and amines converted into chloroorganic compound and chloramines, now the chlorine start to destruct these chloroorganic compound and the chloramines. This is due to the oxidative nature of the chlorine. So at this stage, in this stage 3, the concentration of chloramine continues to decrease because now chlorine attacks on the chloramines and these chloramines get destructed. But due to this destruction, there is no formation of the amine compound again into the water is destructed. That means it gets reduced in the water sample. So in this way, all the chloroorganic compound and chloramines destructed from the water. After that, when we add chlorine into the water, these chlorine attack on the bacteria, and due to the germicidal action of chlorine, the bacteria is killed in this stage. So in the stage 1, 2, 3 and 4, chlorine continuously consumed. But in the stage 1, chlorine get consumed in the oxidation of inorganic compounds. So amount of free chlorine available is 0. In the second stage, when chlorine attacks on organic compound and amine, there is the formation of chloramines and chloroorganic compound which give the same test as the free chlorine give. So in this time, as the chloramine concentration increases, it seems that free chlorine increases. So in the second stage, amount of free chlorine seems to be increased. In third stage, chlorine get consumed in the destruction of chloramines and chloroorganic compound. So again the amount of chlorine decreases in the water sample. In fourth stage, bacteria are killed due to the attack of chlorine. So in this stage also chlorine get consumed. So in this way, the chlorination process get carried out in the water sample for the disinfection purpose. So if we want to break this complete chlorination process, we can divide it into 3 phases. First is the chlorine demand, second is the break point, and third is the free chlorine residual. So what is the chlorine demand? Chlorine demand is the total amount of chlorine required for complete disinfection of water. So when chlorine is added to water, it first reacts with the inorganic materials present. That includes reaction with ammonia, nitrogenous compound and other contaminants. So the chlorine demand is the amount of chlorine required for complete disinfection of water. Second point is the break point. The break point is reached when all the chlorine demand has been satisfied. That means all the impurities are neutralized in the water, and any further addition of chlorine leads to a measurable increase in the free chlorine residual. This is a crucial for effective disinfection because the break point gives the amount of chlorine required for its complete disinfection. Third one is the free chlorine residual. After reaching the break point, the remaining chlorine in the water is available as free chlorine, which is effective in killing bacteria, viruses and other pathogens after the complete disinfection of the water. That means after complete disinfection of water, if further any contamination is there in the water, so there is the sufficient amount of chlorine present in the water as the free residual chlorine, which utilized to kill that contamination. So that is the free residual chlorine. So let us summarize the break point chlorination process. First, when chlorine is added to water, this chlorine introduces the water. Second, chlorine is consumed by existing contaminant. That means after addition of chlorine, we meet the chlorine demand. What is the chlorine demand? When this chlorine get consumed with all the impurities present in the water. Third is the achieving the break point, the point where all the chlorine demand is met. That means water get completely disinfected. Fourth is addition of more chlorine. Addition of more chlorine, additional chlorine is added to the system. It gives the free residual chlorine in the water. So free further addition creates the free chlorine residual in the water. So in this way complete chlorination process is carried out. Two things are important. First, chlorine demand is the amount of chlorine required for complete disinfection, which ends at the break point. After break point, the further addition of chlorine gives the free residual chlorine amount in the water. Now let us discuss breakpoint chlorination curve. If we plot curve between the residual chlorine, that means the free chlorine, and the applied chlorine doses. So this type of curve we obtain. First, in the stage 1, we see here there is the zero amount of free residual chlorine. That means in this stage there is no chlorine in the water sample. So what is that stage? That stage corresponds to the oxidation of reducing compounds by chlorine. So that means this is the stage in which chlorine attacks onto the inorganic impurities. So at this time, whatever amount of chlorine we added to the water, it get consumed. So in this stage, there is no free chlorine in the water sample. After the point A, when all the inorganic impurities removed from the water, when we add chlorine further to the water sample, this chlorine now attacks on the organic compounds and onto the ammonia and forms the chloroorganic compounds and chloramines. And we know that chloroorganic compounds and chloramine give the same test as the residual chlorine give, as the free chlorine give. So since in this stage amount of chloroorganic compound and chloramine increases, so therefore it seems that the free chlorine amount increases in the water sample. But actually what is increasing at that time? At that time chloroorganic compound and chloramine increases. So the curve shows upward movement at this stage. This is the second stage. Point B is the point where all the organic compound and amine compound get converted into chloroorganic and the chloramines. At this point, when we continuously increases the chlorine doses, now chlorine is started to attack on the chloroorganic compound and chloramines, and their destruction is started. That means concentration of chloroorganic compounds and chloramine decreases in the stage 3. Since these both compounds shows same test as the free chlorine gave, so decrease in the concentration of these compound shows that free chlorine in the water decreases. In this stage, the chlorine also consumed with the bacteria. So in the stage 3, curve shows downwards movement B to C. Point C is the break point, which shows that at this point all the chlorine added to the water get utilized for the complete disinfection of water. So at the point C, all the inorganic impurities, all the organic impurities, all the amines, all the pathogenic bacteria get removed from the water sample. So this is the amount of chlorine required for complete disinfection of water. Why? At the break point shows the complete disinfection of water. So what is the amount of chlorine doses added till the point C is known as the chlorine demand of the water, which ensures the complete disinfection of water. After this break point, when we further increases the chlorine doses, it increases the free residual chlorine in the water sample. This is stage 4. So whatever amount we added after the point C, it increases the free residual chlorine. So graph again moves towards the upright direction. So C to D shows the free residual chlorine amount. Basically, the point C shows the break point which ensures the complete disinfection of water. So this chlorine amount must be added to water for complete disinfection. And what is this amount? This, corresponding to this. This is the free chlorine amount remains in the water sample, so that if further water get contaminated, so this free residual chlorine present in the water get destroy or disinfect the all the further contamination. So this is the residual chlorine must remain in the water. Generally it is 0.8 ppm for to save the water from further contamination. So this is the all about breakpoint chlorination curve. So what are the advantages of breakpoint chlorination? First, it improves the water quality because it ensures cleaner and safer drinking water. It removes all the impurities from the water. Secondly, it is cost effective. It reduces the need for additional treatment processes because it removes all the impurities from water, and chlorine is very cost effective. Versatility, applicable to various water sources, whichever type of the water source is there. It may be open source, it may be groundwater. If contamination is there, we can apply chlorination to that water. So basically it destroys completely 100% all the disease producing bacteria or microorganisms from the water. It oxidizes completely organic compounds, ammonia and other reducing compounds. It removes bad odor, bad taste from the water. So in all, it makes water safe for drinking purposes. So now time for the learning check. Read the question displaying your screen and think about that. Which of the following substance is formed before reaching the break point in chlorination? A. Free chlorine. B. Chloramine. C. Ozone. D. Hydrogen peroxide. Yes, option B is the correct option, that is chloramine, because free chlorine is formed after the break point, not before the break point. Ozone is not formed during the chlorination process. Similarly, hydrogen peroxide is also not formed in the chlorination process. So that is why option B is the correct option. So that's all for today's video. To unlock more awesome content, you can hit the like button and subscribe my channel. Thank you so much.